So what we're going to do today is still good practice for the test tomorrow, but there's one little trick to it that shouldn't be a problem, but this kind of happens in grade 10 too, and in grade 10 sometimes it is a problem, but for you guys it shouldn't be. Anyway, we'll see that when we get to it. Couple of things to review before we get into actual solving. The zero product property. So in grade 10, you learn how to factor. You would learn how to factor something such as x, you don't have to write this down, plus 7x plus 12. Right? And it factors to x plus 3, x plus 4. And then you maybe do some other stuff, and then you come back and say, well, what if we add equals 0? So then we add equals 0 here. And what does that mean? And that's where you learn about the zero product property, where if any number of things, the product of all those things, A times B times C times D, you can have any amount. In grade 10, like I said, you would have 2. But you could have more. If the product of all those things is 0, we can deduce that one of those things must be 0 in order for the entire product to work out to be 0, right? You can't multiply any other things together and get 0. 2 times negative 2 is not 0. Some people have that moment of weakness and they think that, right? But no. So if you're multiplying, you have one of those things has to be 0. So that's what we can deduce. Either A is 0, B is 0, C is 0, or D is 0. In this case, it would be therefore either x plus 3 equals 0 or x plus 4 equals 0. And then you could continue and solve to find the value of x. Now that this is also important when you look at, in this case, in this example, or in the examples we have below here, okay, when you look at that compared to when we were just factoring and it has equals 0, it's now an equation, which means it's balanced, which means if we have the skills, we can find the value that balances the equation, right? That makes an equation very different from, let's say, a function where it doesn't say equals 0, it says equals y. This is an interesting question. That's, like, to me, a very profound question to think about. The difference between an equation and a function. Sure, there are simple answers to that, but you could add on to it. If you think about it more and more and more, you could start to understand how different they are, but then, you know, they cross over certainly, right? So if it's equal to y or equal to f at x, when we're doing functions like in the previous unit, then you can represent that with a graph because there's all sorts of pairs of values that satisfy that relationship. There's pairs of x's and y's that go together that satisfy that relationship. But there's, let's say, an infinite number of those. So we represent that with a graph. Now it's equal to 0. So there's going to be a limited number of answers typically in this situation. Not necessarily just one. We see that in grade 10. When you start solving quadratic equations, and you could have 2 answers or 1 answer or sometimes no answers, right? Same thing here. There's different numbers of answers that you can have. Okay, so interesting. So this is an equation. It's got an equal 0. So we're now looking for the value or values of x that balances it, right? And we use the zero product property to talk about that. Something else we want to remember is the discriminant. You may not have heard of it called that, but you've seen it before. B squared minus 4ac. What is it? It's the radicand of the part under the radical symbol of the quadratic formula. Do you remember that? Negative b plus or minus the square root of b squared minus 4ac all over 2a. And so b squared minus 4ac is the radicand, the part under the radical sign. What does that tell us? Very nice. And it tells us a little bit more as well. Does anybody know that? So if the radicand is negative, what would that tell us? Go for it. Well, which one do you think? It means you're taking the square root of a negative number. None, right? Because you can't do that. See, think about it. Think about what it means and where it comes from. Don't just memorize, right? If it's 0, then there's only one, because you take the square root of 0 is just 0. If it's a positive number, when you take the square root, you get two values. So there's two answers. But there's a little bit more to it. Does anybody in this part? What if it's a perfect square? So 0 would count. What are the other perfect squares? 1, if it works out to 4, if it works out to 9, if it works out to 16. Have you ever heard this? That tells us a little bit about the nature of the roots. It means the roots are rational, and what you are looking at is factorable. That's really, really useful. So as you're working through, so in other words, in the last unit, everything was factorable when we got down to the end, but not necessarily anymore. So we could get down to the end and have a quadratic left, and it may not be factorable. So then how would you solve it? You would use the discriminant to determine the nature of the roots. And if it's solvable either by factoring or with the quadratic formula or whatever it is. Does that make sense? We're adding a little bit today because we're not just factoring, now we're solving, but the same thing. So b squared minus 4ac helps when we get down to the quadratic part. I hope you know what I mean by that. You will in a moment. All right, so let's solve the first one. Little tie into the previous unit. It is cubic. So how many answers might it have? Can it have none? See, this is what is so interesting when you start to get a bigger understanding of how, like, this is a class about functions. How do functions and solving equations, how do they overlap? How are they related? And this is something you talk about in grade 10, but people don't fully understand. And you talk about it maybe a little bit in grade 11, but probably not that much. So we'll just do it really quickly. If I get rid of the equals 0 and I say equals y, it's a function, it's a graph, okay? And so let's say I graph it. I don't know if that's what it looks like, probably not, but let's say, okay? It has one x-intercept. X-intercept occurs when y is 0. So now I take y out and I replace it with 0, and I'm solving an equation. Solving for the x-intercepts is the same as solving that function for 0, solving the equation when it's equal to 0, right? You see how that's the same thing? So I can use my understanding of functions and third degree functions to predict how many answers this question might have. In other words, how many x-intercepts does it have? It's the same question. Can a degree 3 polynomial function have no x-intercepts? So this has to have one answer somehow. Not one integer answer, not one rational or something. Like, it could be funky answer, but it's going to have one. Could it have 2? Yes. Could it have 3? Yes. Could it have 4? No. Right? So we know something about this. We have an expectation of what the solution would look like. That just helps our bigger picture understanding. Okay, so let's get started. So how do we, the first thing we're going to do is find a factor, right? It's the same skill that we were learning in the previous unit. We're looking for a factor. So what works? -1. Now this doesn't say f at x equals, so you can do this off to the side. So if it's -1, that means x plus 1 is a factor. Is that what you're saying, right? So, we used to write, like, we would write this, f at -1 equals 0, therefore x plus 1 is a factor. But there is no f at x, so that would be kind of confusing if we wrote that, I think. So you could write it off to the side or just leave it out, like something like that, okay? Or you could just do this. And then we're going to get the result. So this is going to be x squared, and this is going to be -4 equals 0. And let's see, I've got 1x squared and 0. Done. That looks a little weird, but here, I'll fix that. Did I go too fast? Let me do that again. So you remember this little trick, right? You could do synthetic division or something, but remember this little trick. I look at the product of those two, and it's x squared. And this is going to be an x term. So the product of these two things is going to give me something x squared. And those two things have to add up to that. But that is x squared. So that means this has to be 0. That make sense? If it doesn't, ask me about it later. I can go over it again or go over it more slowly, but you could use synthetic division. You get the same answer. Okay, so I get x squared minus 4 equals 0. And that means x plus 1 times x plus 2 times x minus 2, that's a difference of squares, equals 0. Using the 0 product property, therefore, x plus 1 equals 0, x plus 2 equals 0, x minus 2 equals 0, x equals negative 1, x equals negative 2, x equals 2. There's factored form in there too. I could sketch a graph. It's not a function because it's an equation. It's equal to 0. But if I was somehow relating this to functions, I have put it in factored form so I could sketch it. Like there's all kinds of stuff going on here, right? That adds to our understanding. Let's try one more. Try a couple more. Okay, so what's going on with this one?
Just have terms on the other side of equal signs, so you just have to subtract it out and make it into the other side so it equals 0.
Yeah, we always have to set it equal to 0. Okay, let's see. So 2x cubed minus x squared minus 7x plus 6 equals 0. It's funny, our brain sometimes tries to play tricks on us, and this one maybe not so much, but once in a while there's like a question and you look at it and it's not equal to 0, and for some reason you start to think you solve it a different way and start making up your own way to solve it. You could build a rule in your head. The only way we know how to solve these things is by setting it equal to 0. That's the only way that we know how to do it. Okay, we don't have skills or ways of solving it otherwise. Okay? And then on top of that, in grade 10, this always comes up. It's kind of funny. I think it's funny. There's a question that pops up on a worksheet or something, and it's like this, but it's like something, something, something equals 8. Okay? And then every year, like some people try to solve it, and they factor it, and they get, therefore, I guess the 8 product property. So if this times this is 8, either this equals 8 or this equals 8. I don't know how that works. It doesn't work, right? But every once in a while, our brain plays these weird tricks on us and starts to do something else. But if you think about the 0 product property, only works for 0. It doesn't work for anything else. So it always has to be equal to 0. Okay, go ahead. You can try to solve this one. See if you can find the factor. See if you can factor it yourself. I found x minus 1. Did you find x minus 1? Okay, you've had a moment to try. If you want to watch, I'll do the little trick here again. So x times something is going to give me 2x cubed. So this something has to be 2x squared. Negative 1 times something gives me positive 6. So this has to be negative 6. And then that's an x squared term, and that's an x squared term. And they have to add up to negative 1x squared. So if this is negative 2x squared, this has to be positive x squared, which is going to make that plus x. So I get positive x squared minus 2x squared gives me negative x. And I can check that with the x term. So that's going to look like this. Negative 6x minus x is negative 7x. Here's where I would use b squared minus 4ac. We didn't need it in the other one because it was obviously a difference of squares. I'll do it in a different color. B squared minus 4ac is 1 squared minus 4 times 2 times negative 6, which is 1 plus 48. You don't have to like show these steps. You don't have to show any work for b squared minus. You can do it all on your calculator. It is totally for you. So you don't waste time trying to factor if it's not factorable. Or if it is factorable, you don't waste time using the quadratic formula, right? That's what it's for. So you don't have to show steps, but you could if you wanted. And so look, 49. So what do I conclude? Very quickly, without even doing that work, just on my calculator or maybe in my head, it's factorable. Okay, and we could say you can do this, b squared minus 4ac is greater than 0. Therefore, there's 2 roots. Like there's all these things that we can do, right? But again, you don't need to do this because we're gonna do that part anyway. But there's 2 roots. But in particular, it's a perfect square. So what I'm looking at here, this quadratic part is factorable. 2x and x. It's got to be 3 and 2. 3 and 2 plus minus equals 0. Yeah, I don't know why I wrote that. Okay, and therefore x equals 1, x equals 3 over 2, x equals negative 2. Yeah. I think 2x times 2 is positive 4 minus 3 gives me positive 1. And if this part was too fast, this is 2, because we haven't done this yet. 2x minus 3 equals 0. You move the 3 over and divide by 2. But again, you don't have to, you can do that in one step. You don't have to show that work. How could I check my answer quickly? I could take each one of those roots, each one of those answers, and sub it in and see if it gives me 0, right? Or I could do a left side, right side check, although that would be a little bit longer, but it wouldn't be too bad. Whoops, what's going on there? Oh, right? I could check it if you want to check your answers. Nice thing about this stuff that you can check your answers. Okay, one more, I think. What do you notice about this one? Very nice. Save you a lot of work if you notice that up front. And is there any, that always reminds us to look for common factors. I don't think there was one in the other questions, right? It would have come out eventually, but maybe there's a 6 and a 6, but there's nothing else going on. So no other common factor. 6x cubed plus 23x squared plus 25x plus 6 equals 0. Go ahead and give that one a try.